That's, yeah. Don't defame hyperbola. Okay, now, it is a hyperbola because of what you see right there. Two squared terms, one positive, one negative. Okay, now, I notice in this problem that there is no linear y. No linear y. What does that mean about the y's?
They're on the other side.
What does it mean about the y's if there's no linear y? Okay, I think I'm getting the flavor of what I'm interested in here. The y's are already perfect. You do not have to complete the square for the y's, folks, because they are already perfect. Stay with me, otherwise you can leave. So we've got 4y squared minus x squared plus 4x. We have to complete the square, and let's just move the 8 out of the way for now. All right, so let's see. It's amazing to me the number of kids who don't realize that this is a negative number. Now, I did hear you say that it was -4. You are correct. We are adding -4 to both sides. The number of kids who make that positive just because they feel like it is amazing. And they end up messing things up.
Yeah, when you say it's amazing, you make them not do it.
Okay. All right, well. What are you going to pull out of those three? You are going to pull a number out of those three. Please, what number are we going to pull out of those three? -1. Very carefully. When you say that you're pulling a value out, what mathematical operation are you doing? When you say that you're pulling a number out, you are dividing, thank you. So we are dividing by -1. Folks, we're using the distributive property backwards. Okay, so now we have 4y squared minus what squared? X minus 2, right? Okay, now what was on the other side here? 4, that's true. Now what? Divide everything by 4. Giving me y squared minus x minus 2 quantity squared over 4 equals 1. What? It is. It is. Yes.
You know how many of these kind of, like, how many parts of this there's going to be on the test? Like,
There'll be one. There'll be 2 different ones like this where we have to change them from general form to standard form.
oh, it's not going to be like this. Yeah, I was going to say.
That'd be so much.
I know, I was like, I don't know how I'm going to get it all done.
We're practicing, so, you know.
I can't believe you told the whole. What if I was actually getting in trouble? And then
Getting in trouble? What did I tell the whole class?
yeah, I was in Mr. Ginger's office.
They heard me.
What?
I was more making fun of the fact that Mr. Ginder does not know how to pronounce your last name.
I could have said that. Thanks, I'm just kidding. I'm just kidding.
I knew you weren't
He
in
asked
trouble.
me. He asked me what if my teachers had good e-learning, and I said all of them.
Thank you.
You're
I
welcome.
appreciate it.
All of them, but Mr.
Oh, hey. Okay, Mitch. All right. No, I knew you weren't in trouble. Okay, was there another one from this worksheet that we need to go through? Or do we need to continue? Is there more information we need from this question? It's a hyperbola. Do we need more? Okay. Stop disgracing a hyperbola by calling them foci. Seriously. Foci.
Oh, okay. Close.
Closest.
Oh, Mochi. Depending on if you like classical or medieval.
Okay, stop ignoring me.
Are you alright?
Okay.
Are you alright?
All right, what's the center?
Center is 0.
2, 0. Let's see if I agree with that. Yep, good job. All right, now. So we got that. What is the A value? A is the square root of 4. What's this? What's the square root of 4? So that's a 2. B is the square root of 1. I'll do that since that's the hard one. Okay, so how far right and left should I be going from that center to find the edges of the box? 2 units to the right and 2 units to the left. How far up and down should I be going? 1 unit up, 1 unit down. So that's my box right there, my imaginary box. That's not really part of my graph. Okay, so use a different piece of paper. You know? Okay, so what's so important about the box? Asymptotes go through the corners. Okay. Which way does this open? Up and down or left and right? This is definitely an up and down one because the y squared term is positive. Okay, you guys say, oh, and then I'm glad you understand it. I wonder if you write it down somewhere, just so that you can remember it when we get to test time and not say things like, we've never done any problems like this.
We have all the test problems different.
I know, they're so much different.
I forgot.
I specifically designed them that way. Okay, so go for it. Okay, so C equals. All right, what do we do with A squared and B squared? We add them, don't we? We do for a hyperbola because we want to go outside the box. We subtract for the ellipse because we want to go inside the box. Okay, so we know it's the square root of 5. What are we going to do with that distance? Add it to the center. Do we want to add left and right or up and down? Up and down. So we're up here and down here for our foci. What are those foci?
Looks like it's going to be 2,
2 comma.
radical 5.
All right. Plus or minus radical 5. I usually have plenty of space for you to write on my tests. I'm the kind of guy that doesn't like, I don't like that when there's not enough room on a test. It bothers me. Well, it just bothers me, so I wouldn't do that to any of my students. We just added and subtracted from. Okay. All right. Now, can you give me the equations of those asymptotes? Equations of the asymptotes.
The 2 was at 1/2.
No, y.
Y. You could say y minus 0. Or we don't have to say that y minus 0. We could just say y. Plus and minus.
1 over 2.
Ah, up 1 over 2, right? Rise over run.
X minus 2.
You could put y minus 0. I mean, the red pen of death cannot take away a point from you if you put y minus 0. I mean, makes for a good joke, but I cannot take anything away from you because it's technically... y plus 0 makes an even bigger chuckle, but can't take anything away. Then you're in trouble. Yeah. Then we ship you back to Algebra 1. Okay, now, okay, vertices. Give me the purple vertices there.
How many problems do we have like this in the test?
17 million. Vertices. 2, 1. Well, they counted, right? Because they got to get to that spot right there and this spot right here. And 2, -1.
Oh.
Yes, Miss Johnson.
Test, do you care if we do that way or we'll just do like 2 plus or minus 1?
And in that case, no, that would be fine. Yeah, I'm not going to be picky about that. Okay, another homework question from this worksheet before we go to parabolas on the homework. Yeah. 21. Is that what you said, Miss Norwell? 21. All right. Ah, circle. Very, very nice. Circle gets the square.
Same coefficient, that's why.
Okay.
What do we define for a circle? The center and the radius.
Well, like, is this a circle?
It is a circle. Yes.
Like how that equals 25. There being 25.
Miss Krauskopf, it's like there's an echo in the room, you know, like distant in the mountains, you know. You say it, and then, you know, minutes later it comes back to me
Yeah, everybody.
from a different distance. You know, I'm like, wow. All right, let's complete the square here. We got b squared over 4 times a. What are you coming up with? What's b squared over 4a for the x's? That is definitely not a negative number, folks. That is a positive 1. If you add it to that side, what do you have to do? Add it to the other side. I see a lot of kids who forget to add it to the other side. Yes? I'm not going to get mad at you.
But how do you know?
Because anytime, okay, so this goes back to what we just talked about a little bit ago, which you might have missed. You might have missed this discussion. When you look at this question, stay with me, please. Okay, all right, that's fine. The discussion was, what is going on? Why is there no linear y term? And so my question to everybody was, if you don't see a linear y or a linear x, what does that mean? What it means is that that particular variable is already perfect and doesn't need to be completed. So when we go down to this question down here on number 21, you can see there is a linear x and a linear y, so both of them will have to be completed.
So, yeah. Wait, but.
Wait, can you explain that?
Okay. Okay, if this problem, all right, so
Can there be like any like just regular integers other than the 15, like on the other side?
yeah, there can be other integers on the other side. Okay? But the linear x and the linear y are the part that are screaming to me in this problem that there needs to be completing the square so that I would be able to find the center. Yes, it's yelling at me.
18, would you complete the square?
For number 18, whoa, that's not what I... 18, I would just complete the square for x. I would not complete the square for y. There's no linear y term. Exactly. That would be an example of a linear term. Well said. Okay? That's a good... See, that's not a bad question. That was a good question. But you weren't here when we talked about it earlier, so that's why it makes sense. Okay, so b squared over 4 times a. What do you got? 9, you say? Oh, yeah, that's 9. Good job. So we'll add it to the other side, too. Okay. Does anything need to be pulled out of these 3 terms? 1. You're cracking me up. Okay, don't say that at a party, please.
X minus 1.
No. Folks, there's nothing you can factor out of that.
Oh, yeah.
Okay, so -1 was an unusual thing in the last example from the hyperbola. But pulling out a +1, we can do that all day long, folks. It ain't going to change. Okay, so nice try. Is there anything you're going to pull out of these three terms? Nothing. Now, we can factor these. X minus 1 and y plus 3 equals what?
Equals
8 plus 15. 10 plus 15.
20 what?
25.
25. 15 plus 1 plus 9. Oh, you guys. I know, it's been a long day. Yeah, I know. Rough stuff here.
I had to get to 16 and 9. What is 9?
I mean, you guys did fancier work when we were factoring that. Okay. Are we done?
Use a divide between.
Okay, folks, because it's a circle, you could stop right here. Nothing would be harmed if you left it like this. If you did divide by 25 on both sides, no credit's gonna be lost if you make it look exactly like the ellipse. Where you have 25 for your two denominators and 1 on the right side. So I'll take it either way. Okay, but you should be able to tell me what the center is. 1, -3. Can you tell me what the radius is? 5. Yep, the square root of 25 is 5. Okay, so you got any foci on that circle?
One.
They sit where? Which is why we never mention them. No, seriously, stop that. They sit on the center, folks, which is what we showed in that weird picture the other day when we were kind of moving things around and you guys hated me because it was only going around half the ellipse. Who yelled at what?
What?
It's number 20.
Is question 20 a circle?
Yes.
Definitely.
Yeah.
Definitely a circle. Nice suggestion.
Oh, and we are. That's 20, please.
Yeah, because it's already in standard form for us, man. We don't even have to worry about that. Okay. 20 what? 23?
What do you do when you know it's a circle? How do you find the
Goodness,
center?
we just positive.
Find the center and radius?
I don't even
2
know.
square terms.
Okay. Yeah, you take care of it, Miss Coob.
It's -1.
Okay. Question 23. We need to complete the square for which variable?
Why?
Y. There is no square for x, so we can't complete the square for x. All right, now I'm going to push that 16 out of the way. And what are we going to add? B squared over 4a. 12 squared over 4 times 3.
Are we completing the square?
We are completing the square. It is 12, that's true. Nice.
Why is x on the other side? Should it be on this side?
What shape is this, by the way? That will answer the question that's being asked. It's a parabola. It's a parabola. So,
There's only 1 square term.
okay, so what can we pull out of these 3 in the blue box?
3.
3. And that would give me y squared plus 4y plus 4 equals x minus 4. Okay, we're getting closer, folks. What are we going to do? You mean we want to push the 3 to the other side? We could, and we will eventually. So we could do it now, or we could do it later. I don't really care. You can do it now? All right. And yes, Miss Coob, you are correct. That is y plus 2 squared. So if we do the factoring first, that's what it would look like. So Division is the same as multiplication by the reciprocal. Okay, folks, there's what we need.
Then put x minus 4 over 3.
You could put x minus 4 over 3, but the next question I'm going to ask you is, I need to find 4p. And if you write x minus 4 over 3, I'm concerned that you might not know what 4p is.
4p is 1/3.
It is 1/3. So in your example where you put x minus 4 all over 3, that's where I would be just a little bit concerned that you might not see that it's 1/3. So what is 1p?
Why is it?
Because it's sitting right here.
I feel like I would, if I was like doing this, I would think that I would have moved the 3 and I would think that 4p was
0.08.
So you can't have the 3 in front of the square term.
Oh.
In our form of the equation, which is listed at the top of your test.
So it
Well, yes. You've got it. You've got the two on the top of your test. You've got the two different forms of the parabola, and you've got the an example of the ellipse and an example of the hyperbola. Yes. Now it doesn't say which is which, so you do have to know when you look at that equation that that's a parabola. Okay. All right. Now, can you find the value of 1p? 1/12. Thank you very much. Remember, you divide, and division is the same as multiplying by the reciprocal.
Wait, if you divide, it's not 4. Yeah, what if you multiply by 4 over 1?
Okay, division by 4 is the same as multiplication by a quarter. Now, if you were multiplying both sides of an equation by 4, that's how you would get 4/3. But we're not. We're dividing by 4. Okay? 1/12, is that a really big distance to go to from the vertex to the focus? No, that's pretty small, isn't it? Which way does this thing open? It's an x equals y squared, so it would be left or right. 4. Yes, that's a 1. Yep, it's positive. You are right. It is to the right. Nice job. What is the vertex?
If right and left is that x equals y, what's the format for
Y equals x squared.
which one is first?
I got to come up with a cute way to remember that. You know, y squared is your left and right. So y squared, x squared.
Oh, so it's depends on which one is square.
Yeah, I'm trying to come. That's primarily. What is the vertex here? It is 4, -2. That's true. 4, -2. 4, -2. Oh, this is going to be bad. Yeah. 4, -2. It opens to the right, you said. Okay, how far do I go to the right to find the focus? 1/6? I don't think so.
And then your vertex.
How far to the right do I move to find the focus? You're really not paying attention to this. Yeah. Well, turn your desk the right way. So how far to the right do I have to go to find? Because this thing opens to the right. So it is not 1/3, folks. How far? 1/12 of a unit. Holy cow! That's going to be a little bit too hard to graph. So, yeah, somewhere in there, right? I know I did a bad job. Okay, so what is the focus? Well, it definitely has a -2 on it, yeah? What's the x value? 4 and what? And 1/12. Focus. There's only one. All right, now. I'm doing a really bad job of drawing my directrix because how far is my directrix away from the vertex? 1/12 of a unit. What is the equation of that directrix? X equals 3 and 11/12. Thank you very much for subtracting. What? Spelling list? We need to, produce a spelling list. So, nope. No, you're using it to study. Is that what we needed? Okay, my picture is focused. It's going to the right, and it's wrong because I made it too wide. What's the focal width through that 1/12 of a unit? How far should it be across? Right through that focus. 1/3 of the unit. This should be a very narrow parabola. But it's hard with those numbers being that like that.
You do have something to draw that strong test.
No. Wake up, man. There's a test coming. Serious. Get some sleep at night, not during my class. All right. Mr. Query, your question first, and then I'll answer yours, whatever it was. What was? The one on the right here? This thing? That will be printed at the top of your test, and it's a parabola. It's just the generic form. So when somebody asked me, how do I know that 4p is 1/3, I was trying to just demonstrate that we're just comparing it to the generic equation. We know that 4p is 1/3. Okay. Now on that 8-1 homework, you had 60 and 62, you said? All right, let me see if I can open that up quickly. Did I not put 16? Oh, I clicked on the wrong one. Why do I have 8-2? I should have had 8-1. There we go. Come on. Okay. Now, on 60, reflector of the television satellite dish is a paraboloid of revolution with 5 diameter and depth of 2. Remember, we talked about how you would want to center this right at the vertex. Make it easy for yourself. You should be able to tell me what this coordinate is right there that I've highlighted. If the whole thing is 5 across and 2 feet deep, can you tell me what that coordinate is? 2.5 comma 2. Right? Because you went 2.5 feet to the right and 2 feet up. Just kind of imagine, that you're just kind of setting this on the axis. If you've got 5 feet across, this has to be at 2.5 comma 2. All right, now, what's the generic form of the equation of this? We know it's centered at 0, 0. Okay, so no, it cannot be x minus 2.5 squared. because the center is 0, 0. You're making it more complicated than it needs to be. Okay? So, x squared equals 4py. You don't know what 4p is, do you? So we should probably figure that out. Do you have any coordinates that you could plug in? That one up there, thank you very much. Uh, 2.5 squared is not 5. What's 2.5 squared? Okay, because, okay, I know you're thinking that 4p is equal to 5. The focal width is not 5. If you look at that picture right there, the focus is shorter than the top of the dish, so it's not 5. So if we divide by 2 on both sides, we're going to find out that 4p, what is that, 6 1/4 divided by 2, 3.125, I believe. Better check it on a calculator, even though you've all abandoned me. .25 squared. Did I do that wrong? Oh, 2.5 squared. What did 2.5? Oh, okay. Yeah, that's right. And then divide by 2. Yeah, I'm good. 3.125. Okay, finish that when they get back. Doesn't look like it's that hard either. Okay, so I was right. 2.5 squared is 6.25, and we divided by 2. So the value of 4p, the focal width, is 3.125. What is the equation of this particular parabola? Now that you know 4p. Here, I'll change the colors too. I'll start it out for you. How about, oops. Yes.
What is 4p again?
It's on the screen.
Why did you divide it by 2? 3.12.
Are we getting a...
They do have to have super let's see, this is going to be horizontal. Yeah, so it's going to be x squared over 36, y squared over 9. So that is 3. But the vertices are only at the end of the major axis. So I know it says they count the co-vertices on that worksheet. I'm not. Okay, just at the end of the major axis.
And what's the exact equation for the both sides?
Well, for an ellipse, you would subtract a squared and b squared. Okay. Okay. It's right over here. Be patient, and I'll hand it to you here in a second. Okay, that's fine. If you guys want extra practice. If you guys want extra practice, now it's 2 pages. You'll have to give 2 pages to each person. Okay, so I still don't know the answer to my question here. There we go, 3.125y. That's it right there for question 60. Once we found 4p, we knew the equation. All right. Do you have a question about this one?
Yeah.
Okay.
Wait, is this a why is
No, it's just a worksheet.
focal width is 5?
The focal width is not 5. Okay? The focal width is 3.125.
How do you know it's not 5?
Look inside here. You see the focus? It's less than 5.
Oh, it's
They're saying that the depth of the satellite dish is 2. Okay? But the focus is not going to be at 2 units away from. In fact, it's what? To 3.125 divided by 4, so it's, close to 3/4. So that picture doesn't even do it justice. Question about this one? Yes, Miss Hans?
Do you have an answer for this?
I don't know if I do. We might have to make one up. I'll have to look and see if I have one. Okay, 62 is the last one you guys asked about, and then I'll let you work on your own thing. Or you can continue working on that review since you have a test tomorrow. Steinglass Incorporated makes parabolic headlights for a variety of automobiles. One of its headlights has a parabolic surface generated by x squared equals 12y. Where should its light bulb be placed? X squared equals 12y. All right. So we got some parabola that's opening up. There's 2 pages. I did print them. All right, good. What? Stay with me. Okay, stay. Focus on what's going on here. Okay, if you need another one, I got another one here for you. Here, use this one.
It's right, I already got it.
Okay. They said, where should the light bulb be placed? Where do you place a light bulb inside of a parabola?
In the middle.
In the middle? Can you get more specific? At the focus. This is about the focus. Right. So, do you guys know what 4p is from this equation? 12. Do you know what 1p is? Do you know how to use that to find? Yeah, just go up 3 from 0. Hey, what is that coordinate?
0,
0, 3. You answered the question. That's it, folks. That's all you have to do. Okay, is there anything from the worksheet that you see? Let me see if I can bring up a digital copy of it quickly.
Is this the standard form of
Oh, yeah. So, we know that the vertical axis being major, cut it in half. Are you focused for tomorrow? Okay, so 5 up and down. That would be your B value since it's vertical. So now we just need to figure out what our A squared is. Horizontal minor axis of 4. That means we go 2 that way and 2 that way for a minor axis of 4. So what goes underneath that? 2 squared is 4. According to this, yes, because it says vertical and horizontal. It doesn't mean it's always going to be that way. You have to pay attention to the question. Is there anything else on here that you would like help with? We took the vertical major axis and
Wait,
cut
can we
it in
complete the
half.
square for this one?
B squared is, so B squared is 25.
Can you do one on the
One on the back. So is that this one? Up here? Okay, so do we have to complete the square for the x's and the y's? We've got linear x and linear y, so the answer is yes, we have to complete the square. 16x squared plus 32x plus blank plus 9y squared plus 36y plus blank equals 92. Now, can you tell me what shape we're dealing with here? This is definitely an ellipse. All right, so what should you be adding to the x's?
How are you supposed to?
What?
No, let's see that. Oh.
Two squared terms, both positive, different coefficients. Okay, so what have you decided that you would be adding to both sides for the x's? How much are you adding to both sides for the x's?
16.
16 is correct. And how much are we adding to both sides for the y's? Folks, when I do this, just so you're kind of aware, I see 36 times 36 over 36. That's what I see in that particular problem. So I pretty much know the answer is going to be 36.
Wait, is it? It's b squared over 4 times 3.
B squared over 4a.
Oh, I see.
I mean, you don't have to see that. You can type it on a calculator, but if you want to speed things up. I mean, this one over here, for those of you who are interested, that's 32 times 32 over 4 times 16. So in my head, what I did was I reduced that from 32 over 16 to 2. 64 divided by 4 is 16. Now, I could keep going with reducing if I needed to. 2 goes into 4 twice. 32 over 2 gives me 16. Yes, you do? Why? You saw a picture of me? Oh, okay. Didn't know I made it into a video game. So, what are you going to pull out of these three? 16. I'll write that at the bottom here. That's x squared plus 2x plus 1. And what are you going to pull out of these three terms? I'm going to pull out a 9. Good. Good. I'm glad you do. And 92 plus 16, what do we got? 108. Oh, that is 144. Nice. Okay, then you would factor. And then your last step would be divide by what number? 144. Okay, I'll leave that one into your capable hands. Yes?
You only not gonna put the square if all you have is one square term.
If you have just a squared term, let's see if we can find one like that on here. No, you'd have to complete the square for both x and y there because there's a linear term for each of those. Oh, you'd have to complete the square for both of those. So I don't see one on here that you wouldn't have to do it for both.
Is this right?
As opposed to left.